Hi, this video I'm going to talk about the recursive descent parser. It is one of the top-down parser. So what is top-down parser is, in top-down parser, we construct the parse tree from top to bottom. That is root to the leaves, tree will be constructed. So in recursive descent parsing, as I told, it is a top-down parser. It requires backtracking to find the correct production to be applied. The parsing program consisting of set of procedures, one for each non-terminal. The process begins with the procedure for the start symbol. So start symbol, whatever the start symbol that is placed at the root node, and encountering each non-terminal, the procedure concerned is called to expand the non-terminal with its corresponding production. So this procedure is called recursively until all non-terminals are expanded. Unsuccessful completion occurs when the scan over the entire input string is done. That is, all terminals in the sentence are derived by parse tree. So this is a limitation for the recursive descent parser. When a grammar with left recursive production is given, then the parser might get into an infinite loop. Suppose, for example, here we have a production S tends to SAD and A tends to AB or D. So here we have constructed the parse tree from start symbol. So this is a start symbol, that is a non-terminal, that is S. So when we expand S, capital S, so we have a production SAD. So S, then followed by A, then followed by D. So here S is again a non-terminal. So when we expand again S, so again the same production SAD. So this is actually we will get an infinite loop. So the limitation for the recursive descent parser is whenever a grammar with left recursive production, the parser might get into an infinite loop. So this is a recursive descent parser with the backtracking. So here assume that we have a production. What is our production here is we have S tends to CAD and A tends to AB or E. This is our production, and the input string. What is the input string is W equal CAD. This is our input string. So now we construct the parse tree from top to bottom, that is root to the leaves. So here roots is a start symbol, that is capital S. So capital S is a non-terminal. So we are expanding CAD. That is when we are expanding S. So we get a production CAD. Again here A is a non-terminal. So for A we have two production. One is A tends to AB and other one is A tends to A. So when we apply A tends to AB, what is the string we will get is, we get a string CA then BD. This is a string we got. So what is the string we got is W equals CABD. But what is the input string that is given given is W equal to CAD. So what we need to do is we need to backtrack and we need to replace the production A tends to AB by A tends to A. So here we backtrack again, and so what we have done here is, instead of applying A tends to AB, we apply the production A tends to A. So now we get our input string CAD. This is a recursive descent parser with backtracking. So the root node here contains the start symbol, which is capital S. So the body of the production begins with C, which matches the first symbol of the input string. So what is our first input symbol is C. So it matches the first symbol of our input string. Then A is a non-terminal, which is having two production, A tends to AB or A tends to D. A tends to AB, A tends to A. This is not D actually. This is A. This is A. Okay, now we are applying the first production, capital A, which results in the string CABD. As I told in the previous slide. So it does not match with the given input string CAD. So what we have done is we backtrack to the previous step where the production A gets expanded and try with alternate production of it. So now we get a matching of string CAD. So what is the limitation for recursive descent parsing is if the grammar has more number of alternatives, then the cost of backtracking will be high. Thank you.